In the equations involving vectors, we have identified in the addition of vectors satisfies three important properties. Commutative property of addition vectors, a plus b is equal to b plus a. Associative property of addition vectors on the bracket of a plus b plus c, and the a plus the bracket of b plus c. And the distributive property of addition vectors, m times a plus b, which means m times a plus m times b. According to the vectors in a plane coordinate in 2 or 3 dimensional coordinates, vectors in the plane, each point P in the plane is identified with its x and y components, P equal to P1, P2. Using the Pythagorean theorem, we can obtain an expression for the magnitude of a vector in terms of its components. The hypotenuse of a right triangle whose legs are length a1 and a2, hence the length of the vector a is absolute value of a, which is equal to root of a1 square plus a2 square. Let's check about the practical exercises. Consider the vector a represented by the line segment which goes from the point 1, 2 to the point 4, 6. Can you calculate the coordinates and the length of this vector? The first thing, 1 and 2 and 4 and 6. 1 is x1 and 2 is y1. 4 is x2. 6 is y2. Now let's consider about by practical exercise. Y2 minus y1. y2 is given 6 and y1 2. 6 minus 2 which equals to 4. x2 minus x1. x2 is given 4. x1 is given 1. 4 minus 1 equals to 3. Now the absolute value of a, root of 3 square plus 4 square, which equals to root of 19 plus 16 equal to root of 25. Take out the radical, it becomes 5. Vectors in 3-dimensional space. We can also denote 3-dimensional vectors of the standard units of vectors I, j, and k. These vectors are the unit vectors in the positive x, y, and z direction respectively. In terms of coordinates, we can write them as I equal to 1, 0, 0, and j 0, 1, 0, and k 0, 0, 1. These two line segments form a right triangle whose hypotenuse is the vector a, the blue line segment. And the notches on vectors. Number 1. Two vectors are said to be equal if they have equal magnitude and the same direction. Equivalently, they will be equal if their coordinates are equal. So two vectors a, which equals to a1 e1 plus a2 e2 plus a3 e3, and b, which equals to b1 e1 plus b2 e2 plus b3 e3 are equal if a1 is equal to b1, a2 is equal to b2, a3 is equal to b3. Second, two vectors are opposite if they have opposite direction but not necessarily the same magnitude. A is equal to a1 e1 plus a2 e2 plus a3 e3, and b is equal to b1 e1 plus b2 e2 plus b3 e3 are opposite if a1 is equal to minus b1, a2 is equal to minus b2, and a3 is equal to minus b3. Third, two vectors are parallel if one is the scalar multiple of the other. Here is the practical examples on adding vectors. In the example 1, a is equal to minus 1, 2, 1, and b 2, minus 5, 0. On the second, a is equal to I plus 4j minus 2k, and b is equal to 2i minus 5j. We got the correct answer like this. The x1 is given minus 1, y1 is 2, z1 is 1, x2 is 2, y2 is minus 5, z2 is 0. So x1 plus x2 minus 1 plus 2 is 1. y1 plus y2 is equal to 2 plus minus 5 must be minus 3. z1 plus z2, 1 plus 0 is equal to 1. Let's write 1 minus 3, 1. That's clear. That's it. And second, I plus 4j minus 2k. And b is 2i minus 5j. I is x1, 4j, y1. Minus 2k is z1. b, which equals to 2i x2 minus 5j y2. And z2 we can simplify, we say 0. x1 plus x2 is equal to 1 plus 2 is equals to 3. y1 plus y2 is equals to 4 plus negative 5, which equals to negative 1. z1 plus z2 minus 2 plus 0, which equal to negative 2. So let's say and let's write by vector 3i minus j minus 2k. This is all about in the vectors. We will continue on other topics.